Sorry for the glasses. My eye is swollen. It's a bit disturbing. But that's not what we're talking about today. Today we're looking at twisted pair cables. Now these are copper cables, and as the name suggests, these are twisted. And a pair is two. So me crossing my two fingers, you could call this literally a twisted pair. And these are actually more than one pair of cables. They could be four, six, or even eight and above, all bound by copper, right? That's why they are copper cables. And they're all put inside this sort of plastic wrapping. I really wish I could show a video. This is a very low budget video. I'll work on editing soon in my future videos. But hopefully after this, you could quickly Google twisted pair cables and have a look and see. It's it's better that way. But if you need further clarification or a little bit more understanding, you are at the right place. Now, why are they twisted? It's done so that they can provide protection against crosstalk. And we'll discuss in subsequent videos what crosstalk is. But to have a fair idea, crosstalk is unwanted. It's unwanted communication between two pairs or between wires in a cable. Now that could impede or slow down the signal strength, and it causes a lot of problems to network administrators. It's an unwanted problem. In fact, no problem is actually wanted. But there's more. There's more. The reason this exists, despite its challenge, is that it is cheap. It's very cost effective. The cost of installation is also less, and maintenance is also less. Most importantly, it's used for telephone communications and most modern networks, but primarily telephone communications makes use of twisted pair cables. And a key disadvantage of twisted pair cables is that they are susceptible to signal interference, and they need repeaters in short distances to increase the signal strength. What these repeaters do is literally they repeat the signal. So there's something called attenuation, and that is the maximum distance at which the signal weakens. So let's say, for instance, this cable or this twisted pair cable has a length of about 50 meters, and the attenuation happens at the 30th meter. That means at 30 meters, the signal is significantly weakened. And at that 30-meter point, or even before, at probably the 25-meter point, you need to set up a repeater. What this repeater does is it picks up the signal that is being transmitted through that medium and then repeats it. It just carries it forward. So it's like I'm speaking, you can't hear because you are very far off, and I'm speaking to a line of about 50 people, but the 30th person gets it. So what he does is he now speaks up and it continues. So the 50th person hears, and the 60th person will also speak up. That's what repeaters do in the network. And twisted pair cables need repeaters because they don't have that strong signal.